Assalamualaikum and good afternoon. So, my name is Muhammad Khairani bin Arifin. I'm from Group Designer 7. So, this is our process flow diagram. First, we have hydrolysis separator, then saturator, steam reformer, compressor, cooler, Methanol converter 1 until 6, separator, and distillation column. So, for the first reactor, we have hydrolysis separator. So this is the material balance for last sem, and we know that the inlet temperature is 540 and the temperature for each stream is the same. So for the energy balance, we choose CH4, CO2, C2H6, C3H8, O2, and 2, sulfur and hydrosulfide at vapor phase and at condition of 25 degrees Celsius and 1 atm. So we can see that the calculations for each enthalpy is shown here. Calculation. So we managed to fulfill all the information into this table. So from this, we know that the Q we managed to get is this 37233.65 kilojoule per hour, and the power is 10.343 kilowatt. So for the next reactor, we have saturator. So this is the natural balance for last sem. Then we have the reference for each component: CH4 at vapor, CH3, CH8 at vapor, C2H6 at vapor, CO2, N2, O2 and H2O all at vapor. And the temperature we choose as reference is 510 degrees Celsius and 30 atm, since this reactor is non-reactive. So from that we can calculate the H enthalpy. So the calculation are shown under the table. You can see here. So we managed to get all the enthalpy here, and then we managed to calculate the Q. The Q that we managed to calculate is negative 69903.45, and the work is negative 19.41 kilowatt. And the next reactor is steam reformer. Actually, the stream reformer are being calculated back, since it doesn't meet the requirement the lecturer need. So this is the new material balance calculation, and then this is the energy balance. So like usual, the calculation is shown here at the side of the table. You can see the calculation for each enthalpy. Then after we manage to calculate each enthalpy, we get the Q equals to negative 1234070 kilojoule per hour. Per hour.
And I am Vaishnavi, and today I am going to explain about the energy balance for the reactors. Firstly, I'm going to explain about the cooler. So this is the material balance for the cooler, and and this one. So, and now we go and see the energy balance calculation. So for the energy balance, the reference state that we took is 25 degrees Celsius 1 atm, and this is the table for it, and then this is the calculation for it, and finally the Q that we got is 143,864.0426, and then in kilojoule per hour, and in power 0.399585712 kilowatt. And now we go to the Methanol converter 1. So in Methanol converter 1, this is the material balance. This is the the temperature that is entering is 120 degrees Celsius, 20.013 bar, and the exit is 270 degrees Celsius, 30.013 bar, and all these elements are in gas and liquid phase. So now we go and see the energy balance. So assume all elements are in gas phase, and the reference state are 25 degrees Celsius and 180 am, and this is the table for it, and then this is the calculation, and this is the calculation for the energy balance for the enthalpy. And then finally we got Q is equals to Q equals to Q equals to 290,487,6657 kilojoule power, and then in power is 806,910.1825 kilowatt. And now we go to the methanol converter 2. In methanol converter 2, this is the material balance of the calculation, but and the temperature and the pressure are the same. Only change in the mole, inlet and outlet. So now we go and see the calculation for the energy balance. So this is the calculation for the energy balance, and we got Q equals to negative 43371511431 kilojoule power, and in power negative 1204764.286 kilowatt. So and then it goes to methanol converter 3. In methanol converter it's the same but the difference is mole, change in the mole, inlet and outlet, otherwise are the same calculation. And then finally we got Q equals to negative 254,766,532 kilojoule power, and then power is negative 707,684.8114 kilowatt. And then in methanol converter 4, then we go to the methanol converter 4. It's same, and then the difference is change in the mole, inlet and outlet. Then we got Q equals to same calculation, Q equals to 440589043.4 kilojoule power, 1223855.8454 kilowatt. And then we go to the methanol converter 5. So this is the mole for inlet and mole for outlet, otherwise are the same. And then Q we got is 0. Is negative 471094774 kilojoule power and negative 408,637.437 in kilowatt. And finally we go to the methanol converter 6. In methanol converter is the same, just the difference in mole, inlet and outlet. And then mole, inlet and outlet. Lastly, we see the calculation for the methanol converter 6. So the temperature and the pressure are the same, just different in the mole, inlet and outlet. This is the material balance, and now we go and see the calculation for the energy balance. The reference state that we took is 25 degrees Celsius and 180 am. The calculation is this, and then the Q that we obtain is Q equals to 440589043.4 122,385.8454 kilowatt. And now we go to the separator. In separator, this is the inlet, this both are outlet. The pressure, the temperature is 160, and the inlet and outlet are same. It just change in the pressure, inlet and outlet. So this is the calculation for the energy balance, and the Q that we obtain is negative 15644,811.56 kilojoule per mole. So that's all. Thank you. Lastly, we see the calculation for the methanol converter 6. So the temperature and the pressure are the same, just different in the mole inlet and outlet. This is the material balance, and now we go and see the calculation for the energy balance. The reference state that we took is 25 degrees Celsius and 1 atm. The calculation is this, and then the Q that we obtain is Q equals to 440589043.4 122,385.8454 kilowatt. And now we go to the separator. In separator, this is the inlet, this both are outlet. The temperature is 160, and the inlet and outlet are same. It just change in the pressure, inlet and outlet. So this is the calculation for the energy balance, and the Q that we obtain is negative 15644,811.56 kilojoule per mole. So that's all. Thank you.
Assalamualaikum. My name is Alia Aini binti N Manazil. My metric number is 192434. Okay, so I will explain about distillation column. Okay, this is the input of distillation column, and this is the pressure and the temperature of the input, and this is the temperature and pressure of the output. Okay, this is our material balance that we did last semester. Okay, next, this is our energy balance. Okay, we use the reference for energy balance is methanol in liquid and water in liquid at 160 Celsius and 10.7 atm. So, this is our calculation for energy balance. And we get the Q for distillation column is 1364099.958, and the power of distillation column is 378.917. Okay, so we proceed to costing. This is our costing for our last semester, and this is our feed conversions of natural gas. 1,000 tons per year, and this is the cost price of natural gas, and this is the cost price of methanol, and this is the cost price of catalyst that we use in our design. We use only two catalysts, which is nickel and zinc oxide, which is in hydrosulfurator. This is how we convert our price into Malaysian ringgit. Okay, this is our profit for our company. Okay, so for the this is the equipment that we use in our design. So this is power for each equipment, and this is our Q for each equipment. Okay, next, we proceed to operating costs. Okay, operating costs we can divide into two, with variable cost and fixed cost. Okay, for variable cost we have raw materials and utilities. Okay, for raw materials we have natural gas, methanol, nickel, and zinc oxide. Okay, this is the price for each raw material, and this is quantity for each raw material. Okay, For the quantity, we convert the productions of the raw materials from kg per hour to the ton per year. So to get the cost, we times the quantity with the price. Same goes to the utilities. For utilities, we use electricity and water, and we get the price. So to get the cost of the electricity and water that we use, we time the quantity with price. The quantity, we convert it from meter cube per hour to meter cube per year. Okay, next. For the fixed cost, we have labor, plant, overhead, and laboratory. So we use 20% of operating costs. So we get 3.33507 to the power of negative 10. Or how we get this? 0.2 time with the total of variable cost divided by 10 divided by 80. So we get this value. So for the total operating cost, we plus variable cost with fixed cost, and we get this value. Okay, so this is fit conversions of our design, and this is cost of our raw materials, and this is the tariff of our electricity, which is 0.337 per kilowatts, and is this our methanol production rate. This is in kg per hour, and then we convert it into the ton per year. Okay, I think that's all from me. Thank you.